There's something I haven't tackled yet in this channel, and that is surface mount components, mainly because, well, as you may have seen in the recent video, I'm not exactly what you call subtle hand size wise. Let's tame this down for a start. Yeah, that's better. Let's adjust the exposure down here. And I decided, okay, let's make a project with surface mount, and just because, well, I thought it's going to have LEDs, and you need the resistors for the LEDs, and then it just kind of went out of control, as it often does. So I decided to make this sort of circuit board that uses one of these micro USB connectors. Now, in a recent video, another recent video-ish, recently-ish video, I took apart a sort of camping light type rechargeable power bank thing, and it was really shit inside. But some of the interesting components inside were a single component, well, I say single component, a very simple 5-volt boost circuit, which used a little chip, 3-pin chip. It used an inductor, a diode, a capacitor, and that was it, and it got its feedback. But the other thing that really took my interest in that project was the micro USB connector was a through-hole version, and it only had 2 pins. It only had the 2 outer pins, and that makes it really easy to use because you don't have to worry about all those tiny little 5 pins in the middle. You can actually make 2 pads that just basically fill up the whole circuit board in that area, and it makes it dead easy. So I went on eBay at the time and I could not find them. I could find the little breakout boards and things like that. And then other people said, well, they've got them on AliExpress, and they were right. They've got them on AliExpress. I don't normally buy from AliExpress because there's problems getting stuff shipped to Elman from time to time. But they had them, and I got some, and well, here's a project to use them. The logo in the front actually took longer probably than the rest of the circuit board because I had to convert the logo into a bitmap, load it into the printed circuit board design package, and then recreate the logo as a series of arcs and tracks. So this is all generated entirely as tracks to create the logo on the top. This isn't going to be on the prototype circuit board because it won't have a screen print. I may get a small batch of these made. We'll see what happens, just for the sheer fun of it. The layout is designed to be just super chunky. That's why the pads are all isolated. It's symmetrical. Everything I make is kind of symmetrical. Well, symmetrical-ish, because it's just this thing. I like symmetrical PCBs. And it's got the pads isolated by these thin tracks. It's not just one thick track going through them all, just because it makes it easier to solder one without nudging the one next to it. And fundamentally, it's just the USB connector. It's a little loop here with all the resistors going around the outside and then feeding LEDs spread out all around the outside here. With the only point it's nudged slightly is at the area where the USB connector is to make space for it. And it's got 4 holes for pillars. That's fundamentally it. It's designed to just sit up on your table. You could put a cup of coffee on it if you want to guess, and just glow underneath. So that's the design of it. I printed the design out on a piece of paper, put the light sensitive material over the top of that. The light sensitive material, when you put it into the printer, I'm swamping out the top here, that's the this is why I use cream paper, by the way. It's because it saturates out, because I lock the exposure off to try and sort of get a standardized level. Otherwise, if I don't, the intensity fluctuates up and down all the time. But to do the transparency thing, the translucent transparencies won't get detected by some printers, and also it's quite an expensive material. So I tend to print it out onto a sheet of paper like this, then get some sellotape and stick a bit of the material over it, and then print onto the transparency. And you do have to nudge the printer settings for that. You have to make it so that it absolutely plasters the ink down. And the material I use for that, I've not got any right next to me. That's a shame. I've got some other transparencies here. It's a milky coloured plastic, and it's the keywords to search for that particular material are screen print, inkjet, waterproof film, and you'll find it. It's a really odd film. It feels squeaky on one side, and that side just absolutely sucks ink in vertically and just creates this really crisp and jet black outline. Once you've adjusted all your printer settings too, just plaster down that ink, which takes, whichever printer you've got, you'll have to just look for the information in that, because it varies from printer to printer. So then you expose it to ultraviolet light, you put it onto the light sensitive material, expose it to ultraviolet light, develop it, and then etch it. And I would have had lots of lovely footage showing that, except everything went wrong. You know, I like to confess when things go wrong. I don't know if it was the material I was using at the time, it just seemed to get poor adhesion. Either when I was heating it to actually bond onto the material, it didn't quite bond on, or sometimes I kept the heat on for too long and it bubbled up. The moisture that was trapped in the film, because I tend to use water to actually glide it on, it caused little steam bubbles to appear and delaminated, which the first few prototypes lost some tracks as a result, which is not fun. But anyway, I have a complete prototype PCB. This is the second one because I have nudged things slightly. The only things I nudged were these post pillar holes. I just nudged them in slightly once I'd seen how the LEDs were going to look next to them. So let's make this. That's the best thing to do. So in come the surface mount resistors, which I got locally from a eBay seller called Bright Components, and these are 220 ohm resistors. And they're the SMD component size 1206. The reason I chose 1206 is because it's quite big. It's one of the bigger surface mount components. The LEDs, I've actually got a few loose ones in here. The LEDs are also 1206, and I got, initially for experimental reasons, I got some from Salo 2015. Now, this is an eBay seller that I've bought a lot of stuff on from the past, and I've never had any problems with it. And suddenly, I ordered some stuff recently from them. I ordered these, I ordered a little plug tester, I ordered some other things, can't remember what they were. And all of a sudden, all these messages came from eBay saying, we're suspicious about this seller's account and you may not receive your goods pretty much. And, you know, if you've paid, don't worry. If it doesn't arrive, you can open up a case. And I looked at their listings and half of them were gone. And then I looked later on and all of them are gone. They'd basically been shut down. All the stuff I got from Hello 2015 arrived. I've never ever had a problem with them. And I'm very suspicious that the only thing I can think of is that they've been targeted by HMRC again, because the Customs and Revenue in the UK has been targeting companies online, the Chinese companies, who haven't been complying with giving them their wee VAT cut. And I've got a horrible feeling they're starting to shut those companies down now. This means that Hello 2015 will appear probably as Hello 2019. I do hope so, because they had a good range of stuff. But I find that very odd, what's happening. I don't think, certainly all this stuff arrived, I don't think there's actually a problem with Hello 2015. I think they've just been targeted. This, I was supposed to peel this film off the top of this, and the film is not coming off. I shall zoom down. I'm about to start building this. I've chosen to make it with warm white LEDs. These are just a mixture. This was a pack of 100 LEDs. Is it 20 of each colour? No, it must be more than that. Was it 100? Hold on. I'm going to have to count them now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, let's say 25 of each colour probably, because they're tiny. Yeah, let's not start trying to count them right now. Anyway, let's start making this. And to make this, I'm going to be using standard lead-based solder. I'm not going to be using the solder paste around that. I'm just going to use standard components. I'm going to use my standard iron. This thing is not coming off properly. That's it off. And all the resistors have now popped out. Lovely. I can't even start to tell you in my previous attempts of using surface mount how many have pinged. The carpet is probably full of surface mount components. So here are the resistors, and the best way I've found to put these on is just to ignore the value that's written on them, because I know these are all 220, and just kind of like pick them up and put them in a random direction here. I would try and put them with all the numbers around the right way, but they are absolutely tiny. The soldering iron I'm going to use, I could have put the tiny pointy tip on. Let's get zoomed in this, because this is a zoomy type sort of job here. I could have used the fine tip soldering iron. I'm just going to use, I'm not going to put this in my finger, the standard 3.2mm chisel bit, because I've had a wee play and it works absolutely fine. To place the components, I've got a choice of using stainless steel tweezers. Tweeze, tweeze, tweeze. Let's see how this works. I could use the stainless steel tweezers, But I'm going to use, actually I'm thinking maybe I will use them, or I could use, I'm going to have to try them out now, the ceramic tweezers, a common eBay thing, perfect for soldering surface mount components because they are inherently sort of solder proof. Yeah, let's use the ceramic ones. These are also this tip courtesy of Vince, the crew chief in the Embraer 2. They're great for picking up magnets to put them into the colour wheels in moving lights, because being ceramic, most of these stainless steel tweezers have a sort of ferrous component, and they will effectively have a slight attraction to those little powerful neodymium magnets. The ceramic ones are perfect for putting magnets in because they don't have any magnetic attraction at all. Let us use the ceramic ones. The solder is going to be standard 6040 tin lead with flux core. And it's worth mentioning, if you live in the UK or other parts of Europe, the electronic suppliers are now no longer selling lead-based solder to hobbyists. You have to be a company to get it now because of these regulations that they keep introducing. What I'm going to do initially, I'm going to put a little tiny touch of solder. Is that close enough? Yeah, it's good enough. On each of these pads here. Not all of the pads, just one side. And the reason for that is I want to sort of remelt that solder to stick the surface mount component in. So just a tiny little touch, doesn't have to be much. And that will adhere momentarily, the component in that position, until I can solder the other side and then reflow that side. Let us start. So let's grab the first resistor that's the right way up. Hold it roughly about here, flow it, and it's stuck. Next resistor. Place it on roughly sort of central-ish, flow it, and it's stuck. It's not that hard to solder with these components. Goodness knows what it'd be like to solder with the super duper tiny ones. Those, do you know what comes to mind there? Those flip chip LEDs they're using in those cobs these days, they're microscopic. They're like something like 0.4mm by 0.2 or something like that. They're absolutely tiny. So things worth mentioning. As I solder this together, my channel is just heart-stoppingly close to 500,000 subscribers. I could not have ever imagined that was going to happen. By the time you see this, it will probably have rolled over, unless YouTube does that thing which it often does and just suddenly unsubscribes lots of random people. And then people inevitably say, did you unsubscribe? And no, I don't unsubscribe people. It just randomly every month takes thousands down. Dave at EV Blog has been on the go for so long that now let's see, what about Electroboom must be that way as well. He's had so many people unsubscribe that if they gave a silver play button for unsubscribers, he'd have earned one by now. I think I might actually be on my way to a silver play button for unsubscribers as well. It's just part of their thing they do. I'm not sure why they do that. Some of them may be spam channels, I guess, that maybe it may just be that if you don't watch a video in a long time, they automatically unsubscribe you to keep the subscription figures in check. Don't really know. It's strange. See what's happening here. I've now gotten to the resistors that are upside down, so I'm just going to drop them randomly and hope they land up the right way. I'm not sure if this is a standard surface mount technique, but it's the way I'm doing it. I'd also like to mention, it's sort of tied in with the 500,000 subscriber thing. Email. Since July of 2018, I've struggled with email. I've not been able to keep up. So if you've sent an email to me and not got a reply, it's not because I'm just like ignoring everybody. Your email is probably still on my system. It's just I can't actually reply to emails fast enough because as I reply to an email, more will come in. That includes the people who have generously offered things, and I've been stalling on those as well because, well, let's just say that EV Blog mention again. I now know why Dave has Mailbag Monday. He has Mailbag Monday just to deal with the amount of stuff that's coming in because it's huge. And I've not got enough space here to accept everything that people offer. It would just end up... That may be why Dave keeps moving to different workshops as well. it's very nice that people send things in, and some of the stuff is very interesting that people offer to send. And much as I'd like to actually accept their offer, a couple of things come into play. One is that some of the items are huge and heavy, and you can't ship stuff internationally these days. Goodness knows how the Chinese ship stuff out so cheaply from China. Because for me to send an empty bag back to China, it would cost about £4. Versus China actually sending me the goods and the bag for 99p or 99 cents. It's all a bit odd. There's that agreement thing that whatever gets shipped from China has to be delivered by the local office free, effectively. And they've got the reciprocal agreement. I don't think that's working these days because so much is coming from China. I'll just move that resistor slightly. And I'll spin this round and I shall add some solder to these pads. These are all flying on. It's not bad at all. I've also got the option here of using my heat gun to heat those, and they'll all slide into position, but to be honest, I don't think it's needed. I don't mind if these are just a wee bit slightly squiff. It's just how it is. Let's flip these over. All a bit of a learning experience. Right, okay. Let's grab, I've just knocked it over again. Oh, it's pinging. It's pinging. This is a common thing with surface mount components, pinging. It must be particularly frustrating if you have one that is the one that you need to finish a project and it goes ping. Oop, maybe I'll wait for the solder to cool down there. Particularly some of those ultra super tiny components, they're just ridiculous. I should really just do some just for the challenge of it. Make a project with the smallest components I can find and see what happens. I suppose as long as you can actually grab them with the tweezers, then that's fine. Some of the pick and place machines these days are just ridiculous. They're amazing. When I featured a video recently with the flip chip LEDs, Mike of Mike's Electric Stuff sent me a link to a video, and it was a pick and place machine, and it didn't even have the stuff bandoliered. It was big tubs of components, and you just peel the lid back and pour it into the hopper, and the machine sort of vibrates them down onto a platen and then uses image recognition to actually pick the components straight off the platen and get the orientation right, and then it keeps shaking them to make sure the ones that were upside down are shaken around the right way. This is flying together. I say that, I'll probably then look at how long the video lasted and realise that it wasn't actually flying together. It feels like it's flying together. If this is a success, I may be tempted to do more surface mount stuff. Although having said that, there's still lots of places that through-hole is just that little bit superior in terms of construction ease and chunkiness. Better for big fingers like mine. Meat nuggets, as Eric O says on South Main Auto. Excellent, so I'm going to reflow these now, because this is the side that I just tacked down initially, and by adding just that tiny little touch of extra solder, it's going to also add that little touch of extra flux that flows those on and makes a good solder joint. It's interesting to note that when I was soldering the LEDs on, particularly the gallium arsenide LEDs, the reds and the yellows, the LEDs would change colour quite vividly when they heated up. They'd go from being, say, for instance, bright yellow or bright red to a dull orange glow, and then they'd gradually recover again. It makes you realise how overheating LEDs really isn't a good idea. It decreases their efficiency greatly. So underrunning LEDs is always a good idea. So I'm up late-ish tonight. This is a terrible idea because I fly tomorrow. Fly to Glasgow just for a wee quick trip. And flying is never fun. I'll be going by Flyby from the Isle of Man, which means that what used to be a 1 hour flight is now not a 1 hour flight. Oh, I've just pinged the LEDs spectacular. That's excellent. Flybe removed the direct flight to Glasgow Airport, and they now fly via either Birmingham or Manchester. So what used to be a nice fast 1 hour flight is now a 1 hour flight to either Birmingham or Manchester, and then sit in their sweaty lounge, which is so overheated compared to what I normally like. It's just stifling. And then get another 1 hour flight several hours later. It's not fun. Oh well, it is what it is. Now the LEDs have two identity markers for polarity. There's a little tiny green arrow on the bottom that points in the direction of the negative. There's also a tiny little green dot in the top, which is very handy. It makes them quite easy to see the polarity. So what I'm going to do here, I'm going to just moisten the negative pads with a touch of solder. Almost feels like the project's almost complete already. I'm toying with getting a batch of these made. I may shuffle the artwork a little bit. The Chinese are currently on holiday as I do this, because they get their Chinese New Year as their main holidays, you know, and I strictly don't place orders for stuff like circuit boards during that time, because I think the Chinese really deserve their holidays. They work so hard for the rest of the year. The Americans also deserve their holidays. I say that because of that strange work ethic that, you know, they get very little in the way of holidays. They're really, it's 7-day weeks and 12 hours a day, just like Northern Light used to be, in fact. But it's continuous. You get very few holidays. It's strange. In Europe, they've put emphasis on giving people time to actually spend with their families and things like that, you know, just subtle things like that. First LED goes on. The little green dot at the negative side, I say this, I'll probably get all the polarities wrong and the whole project will be ruined. But it's very visible. That's quite nice. And also these are these chunky-ish LEDs. The, is it 1206? 1206 it is. Before starting the project, I printed off a little component guide showing the size of the components, and then I ordered some to take a look at them. That's where Hello 2015 came in. I just wanted to see, are these suitable for this project? Are they going to be big enough to actually be able to place on with big, huge monkey hands? Gorilla Finesse. Yeah, this is looking good so far. I'm only going back to Glasgow just really for a trip, just to go back to Gotham City to visit friends and buy stuff. Probably many trips to places like Poundland, obviously, and see if there's any difference from the stuff they've got here. There usually is a difference between the different Poundlands. You have the in Glasgow there are about 4 different Poundlands in the city centre, and they all have their own range. They seem to choose from a common catalogue. Do you think I'm going to put one of these LEDs in the wrong way around? I guess we'll find out when I power it up. So it's worth popping into all the different shops and seeing what they've got. I know that some of you say you've got a local Poundland and you see something I feature here and you can't find it in your local shop. It may just be purely down to what they chose out the common stock catalogue. For someone who works in steelworks and does scaffold and shit like that, you know, I'm doing quite well for Surfer's Merit, haven't I? I'm not used to stuff that requires quite the subtlety that this does. Nope. He said, dropping an LED. Oh, and I've pinged it. No, I've got it again. The LED has been rescued. So what is the point of the circuit board? It is basically just a little wash of light from underneath it. It's almost like a tabletop logo illuminated thing. It's not got any real purpose as such. You could put a cup of coffee on it. I'm not sure that'd be a good idea. I think I'd want it sprayed thoroughly with conformal coating, and maybe not even use the USB connector if you're going to do that. If I do finalise it and it looks okay, I shall put the file on my website at some point. I'm doing so well. This is I've been distracted and now it's going all pear-shaped. That LED is sticking up at a funny angle. Nope, I'm going to have to do that one again. This is going to be the dim LED that got fried during manufacture. So let's place that LED down again so it's nice and flat in the tweezers, and then place it back on again, and there we go. Fixed. It would be nice if when you dropped LEDs they always landed the right way up, but I suppose it's like toast really. Buttered toast. Always the buttered side down, apparently. Never tested that. I'm sure other people have. For those wondering what temperature I run my soldering iron at, it's currently at 350 because I know there's this sort of thing that people think that soldering temperature is super critical. I just want something that melts big joints of solder really fast. And keep in mind that for a very large portion of my life I used an unregulated Antex XS25, which was what they call a thermally regulated iron. It's just a fixed power, and if it's in the soldering stand it's whatever temperature it gets up to. Never the problem. Right, I need more LEDs. I need more LEDs. That does make sense. I think this was a pack of 100 LEDs. And I'd already used some off a strip, so I need 1, 2, 3, 4, 5, 6, 7 more LEDs. 1, 2, 3, 4, 5, 6, 7. I should actually also include one to drop. Okie dokie. Am I staying in the shot here? The circuit board is gliding about slightly. It's slidey. Nice. This is quite pleasing actually. I'm quite enjoying this. It's not as hard as I was expecting it to be. And the speed, I thought it was going to take a lot longer. But it's not. But that is partly because the circuit board was designed to be quite uncluttered and easy to loads of space for placing things on. It isn't really what you'd call a high-tech PCB. I'm going to have to repeatedly drop these LEDs until they land the right way up. I think it's a bit disappointing that they have banned lead-based solder. It's caused lots of problems. I've got a laptop here that was quite a powerful laptop until just about everything stopped working on it. And it was round about that era that they were starting to experiment with lead-free solder. And it was causing problems because it's very brittle. And the main reason for the reduction of hazardous substances, it's supposed to take lead out of landfill. But in reality, if you look at modern circuit boards, the amount of lead in them is absolutely tiny, and also it's not really in a dissolvable form. It's in the original solid metal form. The biggest problem with lead in landfill was lead paints and stuff like that, where it easily leached into the water. But if you dug some landfill up, you'd find the circuit boards would almost be completely intact. It is in its native form, probably in a less dissolvable form than the lead ore originally came from. So it's all a bit misguided. I'm not impressed by these ecological things that have basically created more landfill, which is not very impressive. But that's what happens, isn't it, when people who are not really fit to make technical decisions get involved. Wow, that was super bitchy of me, wasn't it? Oh well, bitchy it is then. Oh, there's something we could talk about, Brexit, that's going on at the moment. What happened? They're saying, oh no, once we come out of Europe, what will happen? Well, do you remember before the European Union that everything was just fine, and the Dutch and the Germans and the French and Italians and Spanish and British, we all dealt with each other and talked to each other, and sold things backwards and forwards, and everything was just what it was before the union that came in and just introduced shit tons of red tape. So if Brexit goes ahead, I think then, apart from the people throwing toys out of prams, I think it will just go back to what it was before, where there will be basically no change. Who knows? I'm sure that toys will be thrown out of prams though. I'm not really too bothered by it because I don't have any control over what's happening. It's all basically down to a small clique based in London who will do whatever makes them the most money. That's how it works in Britain. That's our biggest export these days, is fraud. Let's flow the solder again, and this is almost ready for the connector to go in and then to get powered up, and that's when I discover that I've soldered every single LED in wrong. That would be impressive. The question is, would I then actually release the video? Since the end of the video, I could actually, because all I'd need to do is put a USB lead on it that had the polarity reversed and not bother with the little plug, the little micro USB connector, which is going on next after I've reflowed these solder joints. I wonder what particular shade of warm white these are going to be. It always tends to be a little bit random, you just never know what you're getting. One eBay seller's warm white is not necessarily another's eBay seller's warm white, partly because I think we're getting sloppy seconds. We're getting the factory off-casts, the ones that they couldn't actually sell to the real customers, because it made all their the LED lamps they made out of them look absolutely terrible. Right, this is looking pretty good. It's looking quite impressive actually, and most of the components are actually lying down fairly, they're all lying down fairly flat. That's very impressive. Right, here's the little connector. And this is also going on the component side. So I'm going to bend the little leads at the back down a tad so that they come into contact with the PCB. I'm going to slip the leads through the two holes that I've made for it. And they're protruding out the front. I've got a choice. I could either crop them off or fold them down. I think I may just fold them down just to lock that into place. So I'm going to fold that out that way and that out that way. It's not folding very well, but that's mainly because I completely missed it with the snips, because of course they get the recess in them. Let's find something that is better. Oh, here's a screwdriver that I can use with such force it slips and scratches the circuit board. That's it. Right, let's solder the pads here. And this is where the joy of this connector comes in, because these are the power pads, and it's just so easy to solder them when you've just got two really big ones. Wow. And now, to lock the connector in position, I'm going to flow some solder down onto the pin. I've got a big pad at the side, and it's going to actually solder the whole connector to the circuit board. And this is where, if I'm unlucky, solder could actually flow into the connector and stop it working ever again. Go on, flow onto the connector. I should really limit the amount of time that connector gets hot. It does have a little plastic insert into it. How's this working? It's looking pretty good. Right, and theoretically now, apart from the fact that connector's slightly squint, let's find a USB lead and plug it in. Oh, actually, you know what? I could use that blue lead with the little magnetic attachment on it. I could use this. This is one of these USB leads that has the magnetic pin end. I got it for my mobile phone to try out. I'm not comfortable about the fact that the pin sticks out like this. There's no power in the USB connector, micro USB connector to the phone, but to me, it makes it vulnerable to static electricity much more than the actual socket, because it's got the screened metal surrounding that would stop static hitting the connector, so to speak. But as soon as you put this in, it does kind of expose it to static. I'm not really sure if that's an issue or not. Let us get a USB power supply. A little fetching pink one would be nice. There we go. And see what happens. Oh, there's a dead LED. Is that just round the wrong way, or is it not soldered in right? Oh, there's two dead LEDs. Have I soldered them in the wrong way round? It's possible. Let us get rid of those, or let's reflow them temporarily. That could also be down to the resistors. The resistors, actually, you know what? I think I have slightly missed the solder in that resistor. Ah, there it is. Right, I'm going to have to make sure I push the solder iron right up against the component. Is the same applying to this one here? Yes, it is. Okay, so shoddy resistor soldering. That's looking pretty good. Now, the next thing I want to add here is a little bit of hardware which I've put into a shot glass. And it's these little brass hex spacers. So I'm going to thread them through like that, and they fit nicely between the LEDs and they don't go too near the track. First time I'm seeing this with the spacer in, because I did nudge that pad for the spacer, the hole, away from the track a little bit. It's looking fine. So I've not finished this design yet, but when I've finished it, I shall put this up on the website probably. So that if you've got the facilities to etch your own circuit boards, well, that's a little magnetic connector coming off. If you've got the facilities to etch your own circuit boards, you can then basically make one. If you look at the section that's got all the printed circuit board files on my website, let's zoom out here, then you'll see there is a link to the package I use for designing them, which is Sprint Layout. And they offer a sort of test package, but it also lets you load the files that I put up there in and print them out. And also have a replay with the package. I like it because it's very down to earth. So there we go. This is the illuminated platen. So let's turn the light off and take the exposure off. This is where the exposure just absolutely swamps out now. Oh yes, it did. And right. That looks quite stylish. I quite like the fact this is translucent. It actually makes it look quite neat because you can actually see the image through from the other side. You can also see the back of the LEDs. Now, interestingly, I had another circuit board. Where is that? I've dropped it. I had another circuit board with I'd been testing various colours on. It was the first prototype of this. I can't see that, mainly because just give me a second here. No, where have I dropped it? There it is. So here's the other one, and you can see what the other colours look like, because this one, which had a few faulty tracks on it, that was the etching problem I had. It's I tried various colours. I also tried different styles of LEDs. So if I plug this into another power bank, let's try plug it into this little Asda-ish power bank, or Walmart-y power bank. This one has the red along this side, warm white along this side, and then it's got 2 green, 2 yellow, and 2 blue. And you'd think there are none under here, but in reality, those are the 2835 LEDs, so they are there. But the nice thing about the 1206 LEDs is they actually cast light through the other direction, whereas the other ones have the housing that blocks it. And you'll see that from the angle of projection here. The 2835 are good at shining light out, but not spreading it sideways, because fundamentally the 1206 are basically a little tiny circuit board with the chip in the middle and then just something covering it so that the light spreads out in all directions, which makes it better suited to these. That looks pretty good. I think that's turned out okay. It'll be nice with the logo, but that does leave the question. I'm just about to turn the light on. Shield your eyes. That does leave the question. If I get a screen print, well, I will be getting screen print, I'll get the logo on the top, but I'll also be getting a solder resist layer. What colour should I use? Because if I use black, which is my preferred colour, it kind of hides the tracks. If I use blue or green, it's going to really attenuate these colours unless blue and green LEDs are used. Not really sure yet, I've not decided that. Red would probably work. White would be an interesting one. Do you get white solder resist? I guess you probably do. Or would it again block the light? The pet hate of the black and white solder resist is they hide the tracks, and that might actually be an important issue here for something that you want to be able to see where things are going. But that's worked out okay. that is looking very neat. And tonight's refreshment was a Jägermeister again. Tonight's sweetie was from Iceland again, courtesy of Magnus and Alex. It's I think I can pronounce this correct this time. Sirius Pralin Chocolade, which means praline chocolate, milk chocolate. Med minty filling, which I'm guessing that means minty filling, particularly with the minty leaves. And certainly if I just nibble a little bit of this, it has the minty filling inside. Oh, it's clear. I didn't know it was clear. White and clear. Interesting. I'm going to enjoy that right now. But not until after I've finished making the video. So there we have it. Work in progress, but the first proper surface mount project, and it's actually gone together quite well. So that's actually looking quite promising. And I'll let you know when I've updated this, when I've finished it. And then I will probably publish the files on my website for you to download. And I'll get a wee batch made just for the entertainment value of it. That connector is so easy to knock off. But it's also very easy to make. Yeah, quite neat. It's worked out quite well.